All right, so it's 6:35 by my watch, so we're going to go ahead and get started. Um, Welcome to training. It's exciting. It's the first session here. Don't worry if Sam, if you haven't downloaded it, or anyone, if you haven't downloaded Inventor already, don't worry about it. We're going to show you how to do it at the end of the lecture today. So by the end of today, you should have it downloaded, and it'll be all good. Yeah. So yeah, as I mentioned before, if you've already learned Autodesk Inventor, today might be a little bit of a review, or if you're already familiar with another CAD program like SolidWorks. But as an introductory lesson for training, this works, and we'll be learning more than CAD in this training. So if you're worried about not learning anything, don't worry, you'll learn something. So just an introduction. My name is Sam Walters. I'm a second-year mechanical engineering student here. I'm part of the Robo Racing mechanical team. I'm from Northern Virginia, and in my spare time, I do swimming. I do swim club here at Tech, so that keeps me busy. I really love bowling, and I play video games from time to time. And now you'll meet Tomas, who's the other trainer for today.
Hey guys, so my name is Tomas. I'm effectively a fifth-year mechanical engineering student. I have a concentration in mechanics and materials. I've been with RoboNav the past 5 years, and I'm originally from Manhasset, New York, so that's a little east of the city, so like 20 minutes from Queens, if you know where that is. And my hobbies include like doing lots of music and also playing lots of video games. So if you guys are interested in video games, we have a gaming Discord, so y'all are welcome to join. That's just for fun.
All right, and Tomas and I are going to switch off on Tuesdays. So Tomas, if you could just keep an eye on the chat and answer questions that come up. Yeah, guys, feel free to ask questions at any time, whether it's in the chat or if you want to interrupt me, that's fine. But any questions, we got answers. Oh, and these are the people you'll meet if you go to the Wednesday trainings. Again, you don't have to go to both, you just have to go to one of each. Nice, Keaton. Okay. So we're going to start from the basics. What is CAD? So I've been throwing around the word CAD a lot in the emails and already today. So we're just going to start from the basics. It's computer-aided design. So whenever you see people with 3D models of things, they've made it in CAD. And it's really great for rapid prototyping. So if you have an idea for a design and you want to see what it would look like in 3D space without necessarily manufacturing it, CAD is what you want to do. And for those of you who are in ME 1770, then you already know that hand drawing is also a great way to do things. But sometimes it's nice to see things in 3D. So just some basic terminology as far as CAD goes. Sketches are the lowest level of organization. It's as if you're drawing on a piece of paper. It's just two-dimensional, basic geometry stuff that can be extended into different, they're called features. So for features, it's when you extend these sketches into 3D space for the first time. It can be an extrusion, which is basically taking a sketch and just shooting it out, or it can be a revolve. So if you have an axis in a sketch, you can revolve around this axis, and we'll be showing all this later. And then once you have these features, you can build them into parts. So like if I made a cylinder, is that my whole part? Not necessarily. Maybe I want to add on some rectangular prisms onto this cylinder or something like that. A part is made up of a lot of features. And then when you take all these parts and stick them together, that's what makes an assembly. So when you see like the full assemblies of Rigatoni, the go-kart for robo racing, that's an assembly made up of a bunch of different parts. And assemblies can also be made up of other assemblies. With Inventor, you can stick a lot of things together, and it works really great. So we'll talk a little more about CAD Space. It's in 3D, as I've mentioned, so we're dealing with X, Y, and Z coordinates. So if you're in multi by chance, then you might be a little familiar with it, but we're dealing with 3 different planes, and you'll see them later. But essentially, what you got to know is we're going to be dealing from low complexity to high complexity. And that's what the process is with Inventor and CAD in general, all the time. So I'm going to show you what this looks like in Inventor. You don't have to have this pulled up. I'm just going to show you, and then we can go over it in Inventor after the lecture. But when you start a 2D sketch for the first time, this is what you're looking at. You're looking at these 3 planes that you can start a sketch on. And when you're drawing sketches, computers don't necessarily know what you want. So if I want to make a rectangle that's 3 inches by 5 inches, I have to tell the computer that's exactly what I want. Otherwise, it'll say, I think you want maybe 2.5 inches by 4 inches. But if you don't define it, the computer doesn't know. And that goes for measurements. It goes for other constraints like parallel or perpendicular, angle constraints, anything like that. And so this is just a little quick example of creating a rectangle. So as you can see, they started a sketch, chose a plane to put on it, to use the sketch on. They clicked the rectangle in the top left, and then they just clicked and dragged, or not dragged, but they just opened up a simple rectangle. And that looks pretty easy because, well, it is. So you'll be able to do this later. So as you might have noticed, the rectangle was 2 different colors. And these colors do have a meaning. So blue and green are in these slides, but the colors may not be exactly what you see on your screen. Different versions of Inventor use different colors. But essentially, one of the colors means that the constraint is known. It means that everything there is to define about that part of the sketch is fully defined. But the other color, green in this case, means that something isn't necessarily specified. So for example, in this rectangle, it knows that its corner is going to be at the origin and that these 2 lines are along the axes, but it doesn't know how long these lengths are. And so it makes them green so that you still have some constraints to put in before the computer knows what you want to do. And the best practice is to have all the same color of the constraint before you move on. If you leave things undefined, it can kind of break when you try to change things later. So you'll notice that there's going to be a whole constraint area box in Inventor when you open it up. And so these will do a lot of different things. So we're going to cover these in more depth a little later in future lessons. But these are the things that you'll use to create your constraints and make them better than just trying to type things in manually while you create them. Like, for example, when I make a rectangle, I can define the lengths as I make it, or I can dimension it afterwards. So the question, ask yourself, if I move one line, what will break? When we say break, it means what will change that we don't want to change? Like if I made a rectangle and I wanted to change a side length, what would happen to the other sides? Would the angles get messed up somehow? We want to make sure everything is locked down. And so in order to fix things, we're going to use these dimensions and constraints. So the easiest way is to take something that's green and measure it with respect to something that's blue or purple or black. I think in this current version of Inventor, purple is unconstrained and black is constrained. You'll be able to see it when you open it up. So for example, this top line used to be green, but we're going to say that it's 3 inches away from blue. And that will lock it down and make sure that it's fully dimensioned. So maybe something isn't working. And when you try to click dimension, it'll say, dimensioning this part will overconstrain the sketch. And you'll be kind of confused as to what that means or what you can do from there. There's actually a handy little function. And when you right click in Inventor, you'll see this huge palette all these different options that you can choose. And most of these you'll just be able to experiment yourself through. We're not going to necessarily explain what each of these do, but show all degrees of freedom is super useful because what it will do is it will reveal different degrees of freedom that are in your sketch. So for those of you who don't know, there are 6 degrees of freedom. There's it's a movement in the 3 planes, and then there's rotation in the 3 planes. Which one did I forget? Forward, and then, what was it, Tomas?
Right, so like if you have like your X, Y, and Z, right? Imagine this is your coordinate system. You can rotate about X, you can rotate about Y, and you can rotate about Z, right? In a 2-dimensional sketch, you really only have 3, let's call it degrees of freedom, just because like you're on a 2D plane, so you only have to worry about X and Y. So rotation about Z, and then translation in X and Y.
Right. Yeah, exactly what he said. So when you can see all those degrees of freedom, then it will show you where exactly you need to lock down before it doesn't move. Another quick way to make sure that you're fully constrained is if you try to click and drag stuff around, if it can move, then you still have something to constrain. So moving on to features, we're going to do a couple basic ones. So as I explained, extruding is just doing one, straight motion. So if I took a circle and I extruded it, it would become a cylinder. Or if I took a rectangle and extruded it, it would be a rectangular prism. Revolve is exactly what it sounded like. So if I had a circle and an axis and I revolved around the axis, I'd create like a donut. Holes, self-explanatory. And sweep is something that is a little less common, but let's say you want to create a more unique shape that has a lot more curves than you can easily make with extrudes. A sweep would be able to make like weird, not necessarily radially symmetric loops. Like if you wanted to make a big belt, a sweep would be used for that. And that's something we use in robotics to model belts for like gears and chains and all that. So here you can see the person clicked the extrude commands in the top left, and then they clicked their sketch. And all that does is shoot it straight up. And then you can define how far you want it to extrude. Same thing with revolve. You just click the revolve command, click your sketch, and also click the axis that you want to revolve around, and it will all revolve. So something to keep in mind is when you click one of the sides of your shape, then it will completely fill in. There won't be a hole in the center. So like if you made a semicircle, a half circle, and you revolved around the middle, you'd make a sphere. And you can define if you want it to revolve 360 degrees or anything between 0 and 360. And then hole, same thing. So this person has, it's hard to see, but there's a small plus sign called a center mark that the person is clicking on, and that's what creates the hole. And with holes are special because you can thread them within Inventor without having to like manually do it. So that's really useful when you want to design screw holes. All right, so looking back to the sketch, let's say we created a prism with these set dimensions. You see it's all purple, so we all know it's good. So it's 3 inches by 7 inches. And when we extrude it, we end up with just a feature. And even though it's just a feature, it's also considered a part. It has the same file name. And essentially, it could be a part. Maybe that's all you need. And so, as I mentioned, parts will all have the IPT ending. And so, when you look at the feature tree on the left of the screen, when you pull up Inventor, you'll see that you've got your main part, and it'll have a name probably. And then these default things that you can probably ignore for the most part. And then you'll have sketches featured under these features that you make. And as you use Inventor, this will all make sense. So if you're feeling like I'm going really fast, it's because it's hard to just watch without doing it yourself. And then assemblies, I'm not going to show you exactly how to do it yet, but when we have all these individual IPT files, then you can stick them all into one assembly file, and then there are different options. The same way we constrained sketches, you can constrain parts together. And it can be used to show that things are going to fit together. In theory, it can be used to show how many screws you might need, or to make sure that everything lines up the way you want them to. So just recap of what I've been stressing this whole time. You start from the lowest complexity of a sketch, and you move to 3D features, which combine into just a 3D part, and then you combine all of those into an assembly. And so, if you have any questions, go ahead and ask in the chat. But otherwise, I'm going to send a link here in the chat. And this is just a little survey for us to get to know you. And I'll give it a few minutes before I keep going. But yeah. That was kind of fast. Yeah, that was a little fast. Oh, is it? Oh, my bad. All right, let me see if I can get this better. I can stop sharing for now, so you don't have to watch me bumble around. Here. Okay, try that one. Okay. Yeah, it's all pretty basic stuff. Usually after lectures, what we're going to do is play a Kahoot. So you have that to look forward to in the future. It's just like it's going to be reviews of what we talk about in the lecture. And if you feel like you don't have any experience with any of this stuff that I mentioned towards the end, totally fine. We don't actually do anything with machines directly in training. So even though we're in COVID, it doesn't affect us. It's just, if you've used the machine before, then you might know what it's capable of, so we can talk about design process. Sure.
I guess it does count, right?
Yeah.
Like it just doesn't mean that you. So like for the SEC, we have a system called SUMS where you have to be trained on it. So regardless of what your experience is, like you're gonna have to go through training in person. This is true.
Yeah, and if you haven't been trained at Tech here, like it's only been a few weeks. I don't expect anyone to be trained at Tech unless they're not a first-year student. But if you use them in high school, or use them like at maybe if you've got an internship or use tools, like that counts.
Or you could be an absolute mad lad and have your own CNC decked out and everything, like young the god.
Yeah. Yeah, if you have a CNC, just like a personal one, you should call me. I have some uses for that.
Also, I'm just gonna remind you guys, like, To put things into perspective, even though I'm a fifth year now and I know like, or at least I think I know a few things, right? I came in knowing like nothing. So you're gonna be all right, okay?
All right, let me see if I can throw a poll in this chat. Can I do that? Maybe not.
There's Polly. I think that Polly can do.
Yeah, there's this Polly. Let's see here if I can. Ooh. Okay. Oh, okay. So I guess other people use Teams. That's nice to know. All right. So I'm going to throw in the mechanical training chat itself a little poll. I'll have to sign into account. Okay. Never mind. Going to do that next time if I do it again. I'm going to just, if you haven't downloaded Inventor yet, then send something in the chat. Anything.
Give me an F in the chat, guys.
Okay. Okay, so you have a previous version. It's best if you download the new version, yeah. So I'll go through it. If you've already downloaded Inventor, and it's the most recent version, let's see, 2021, then you can go ahead and get started in the Week 0 CAD Guide. I sent that in an email yesterday.
I'd recommend just putting that in the chat anyways.
Oh, true. That's a good idea.
Yeah, like doesn't hurt.
Yeah.
And also, as I think Nicholas is mentioning, we do put this in the CAD guide itself. But if you don't, even if you don't have Inventor at the moment, you can go ahead and use Inventor through mycloud.gautech.edu, right? That should also be in the CAD guide itself.
Yep.
So I'm also going to drop mycloud.gautech.
Yeah, I'm going to show you guys how to do it. So, if you haven't downloaded Inventor, then I'm going to do that just in a second. And then if you have already used CAD and want something to do, but not necessarily just one little thing, then I've got this advanced CAD guide, which is not too much more advanced. It's still designed for people who are just learning this week. So if you're looking for an extra challenge, this advanced CAD guide is a great resource. But yeah, to answer the question, is it okay if we use MyCloud always? Yeah, if you really want to, that's fine. The only issue is if you want to use Inventor offline, or if you want to, I don't know how saving things works in MyCloud.
So the thing is, depending on what team you're on, because I'm not sure what the situation is for others, but essentially, each team does have its own file system, like Dropbox, for example. I'm not sure if the BattleBots teams use Dropbox anymore, but we also have GrabCAD. We used to use Vault as well, and that might honestly be the bottleneck for you, because in MyCloud, which I'm going to answer Sam's question in the chat, MyCloud is essentially just a virtual desktop that you can access programs on. Right, so you're essentially just remoting into a desktop that exists on Georgia Tech, okay? And that desktop itself is going to have Inventor, it's going to have SolidWorks, it could have some computer-aided engineering software like FEA or CFD and stuff in there. Does that kind of answer your question? Okay, perfect. And essentially, the problem with using MyCloud for everything in RoboJackets is because you have limited space that you have allocated in there. So if you need to do everything through GrabCAD and your team has a lot of stuff in GrabCAD, IGBC has several gigabytes, or not IGBC, sorry, RoboNev has several gigabytes worth of CAD stuff that we need to work with, and I'm sure RoboRacing does too, then that could potentially become a problem. But yeah, in short, I would also just ask your mech leads just in case. because obviously speaking as like a RoboNav member, I'm not going to be able to represent what, each team has to deal with, if that makes sense.
Yeah, so he was mentioning GrabCAD, which is something I have pulled up right here. Essentially, every once in a while I come in here, and every time someone edits a file that we're all sharing, it gets uploaded and I can just download it. And so these are all Inventor parts that, either they've added or they've edited, and I just have to download it and I can reference stuff that other people have been working on. But yeah, so you'd be relying on that if you're using MyCloud or whatever your team uses. So the email list, Tomas, can you get the link for the email list?
Yeah, I'm gonna look. It's on robojackets.org, right? I'll take a look at it. If not, I'll ask in IT help desk. But okay. I'll get back to you in a second.
Yeah, so I'm going to show you guys how to download Inventor or access it through VLab. I've also made a YouTube video about this, so if you want to do this on your own time, I've put that together for you. You just have to look at the RoboJackets training YouTube. RoboJackets. Oh gosh. And I've sent these links in the email, so it shouldn't be too hard to find. So yeah, if you go to the video to this first mechanical training week 0, launching Inventor is what you're looking for. But I'm going to show you everything right now. So yeah, in the week 0 CAD guide, it starts off with this. So we're going to start with using VLab. So this is for anyone who is like not on a Windows and can't necessarily download it. I'm personally on a Mac, so I'm accessing Windows through a boot camp like hard drive partition. Wouldn't recommend necessarily, but if you want to do that, that's an option. But anyway, a VLab is when you go to mycloud.godtech.edu. And you just put in your generic or your general username password for Georgia Tech stuff, and you'll come across all these different desktops that you can see. So you're going to pick the COE 2020. I need to update this picture. It's from 2018. You need to select 2020, and you'll just be able to see like a Windows desktop that has Inventor as one of your desktop icons. And all you have to do is just click on that, and you're good to go. Super easy, super fast, not hard at all. So if you want to install Inventor, then all you got to do is go to this website. Here, I can send this website in the chat. The website, mycloud.godtech.edu. Or I can show it again. Actually, no, it's if you scroll up in the chat, then you can see it. But yeah, when you're on the Autodesk website, you just have to create an account. It doesn't matter what email you use. I personally use my godtech.edu email just to keep all my school stuff on one account. And then just download the educational license. If you follow the instructions, it's pretty easy to work stuff out. And then when you have to choose either Inventor Professional or just Inventor, you're going to pick Professional. And then you're going to have to give it some time to install. It's a pretty big application. So you're going to have some space. You're going to have some time. And if you're having a lot of trouble, you can contact #IT Help Desk on the Slack. Or you can contact Training Help Desk on Slack. There's always going to be someone who can help you out. Let's see here. Yeah. So if you're just downloading Inventor now, then that's fine. The CAD guides are available at any time. Something else I forgot to mention. In this training YouTube, for each week, I've created some CAD guides tutorials. So like if you want to see someone working through each of these step by step, or if you want to remember how to do one thing in particular, you can just reference these videos. So the CAD guide is something that you can work on your own time. Since we blew through that lecture pretty fast, I might just do this and show you guys, and you can follow along if you want. I think that's what I'm leaning towards, just so you guys can see what Inventor looks like. So let's see here. All right. Do you guys have any other questions? All right, well, I'll take your silence as a, hey, show me what to do. So I'll show you what to do. All right, so if you want, actually, I'm gonna just keep Inventor on this page and, oh, wrong one. I'm gonna switch my screen share to this screen. All right, so what you're looking at right now is the default homepage of Inventor. By the way, if you guys need to go or want to do this at a different time, that's totally cool. Like if you already know Inventor and maybe you blew through this really fast, or you feel like you don't need practice because you're really into it, you guys can get going as long as you clicked on the attendance link at the beginning. That's it for me. Yeah, reach out to us with any questions. We got the Piazza, we got the Slack, it's all good. But returning to Inventor. When you first open it, it's going to be like, do you want to start learning or start working? And so you'll just click start working because you're learning now. You're learning here. So we're going to open up a part. And there are a couple ways to open up new files. This is the easiest. You just click part. Actually, give me a second. I've got a fancy mouse that I like to use. Oops. All right, so you're looking at just a blank 3D space. And the place to always start, no matter what you're doing, is top left corner, start 2D sketch. And can you guys see this clearly? Just confirming. All right, sounds good. So you're going to start here, top left, start 2D sketch. And just as in the slides, you'll see these 3 planes. And if you just hover over one and highlight, you can click on it. It's going to be left click for a majority of these things. Yeah. By the way, it doesn't really matter what plane you're starting on. Some Robojackets teams like to keep it standardized, like to make sure things face the right way when you put them in assemblies, but it's not that hard to correct them. So I just pick a random one. And so I'm going to go to these slides here. And I can't have slides up at the same time, so if you want to follow along, just pull them up on your own screen. Okay, so we're going to start with circle. Your basic shapes are going to be up here. These drop downs are if you want to create some more, either the same shape with different points. Like with rectangle, I can create it with 2 points for each corner, or I could create it with 3 points to define one length, and then width. I can go from the center, which is cool. But we'll just start with the circle. And you'll be like, okay, is that this measurement we're seeing in the middle? is that a radius or a diameter? And the answer is actually a great question. Okay, so if you hover over something, you'll be able to see a little more documentation about it. So this tells us it's the radius. We can confirm it in a little bit. So what do we want the radius to be? Well, actually this, oh, you see the arrow here? That means it's the diameter. If it were radius, the arrow would be between the edge and the center point here. So we'll set it to 3/8 inch. And you can define it with decimal value or fraction, doesn't really matter. So 3/8. Yep, 0.375. Yep, super easy. And you'll see it turns black because it's fully constrained. Before, it was purple. So now we're going to create another circle. And so I'll just left click here in the center again. And when you highlight, when you hover over, and it kind of snaps into place with the green. The green means it's trying to snap into a particular geometry that is guessing you want, which is correct. I do want the center here. Now, I could create a second circle using the basic shape, but this time we're going to use one of these things up here. It's called offset. And so what offset does is when you click on a shape on a geometry, it's defined by the distance from the original. So as you can see, as I get close, this dimension goes really small. And then when I get closer or further away from the original, the measurement gets bigger. So we're going to go in by 1/16 of an inch. And I could say inches. I could type in inches manually, but my document itself is in inches. Something to note is, if I wanted to make it millimeters, I can just type in millimeters. Oh, millimeters. Sorry. Never mind, I can't do that right now. Let me just do this example. 0.3 millimeters. There we go. And it'll be a little small. But sometimes if your part is referencing with millimeters, that's all you have to do. You can also change document settings later. I think I'll show you how to do that in a different CAD guide. But for now, we're going to stick to inches. So now we've got these two circles, and so we're going to finish sketch because we're done with the 2D shape. And now we're going to click extrude. It's up here. And this box will pop up. Actually, hold on, you might not be able to see this box. I'm going to change my share permissions again. Okay. Someone say something? Oh, okay. Yeah, so you'll see this box pop up. And so profiles is going to be asking for the face that you want to extrude. It sees these two different boundaries, and it's wondering which one I want in particular. And to answer its question, like I could select the whole thing, I could select just this outer ring, I could just select the inner ring or the inner circle. For this case, we want this outer one. I could see through it. And you can experiment with your mouse that you have on rotating things. You can also use this top box and just left click it around. As you get to practice, it'll get pretty easy for you. I personally have a 3D mouse. Wouldn't recommend buying one unless you're like super familiar with it and like can't work without it. But anyway, we're going to go 1.8 inches. it'll automatically adjust and show us like a prediction of what things will look like before we finish. So now we're going to make another sketch. And when I start 2D sketch, instead of seeing those 3 planes, I only have to choose a flat surface. So I could choose this bottom surface where I started from, or I could choose this top surface which I created. So I'll click this top surface. And now we're going to do what's called project geometry. I know it looks like project geometry, but because of the way it's used, it's pronounced project. So we're just going to click project geometry and then click the circle so that everything's highlighted. And you'll see that we get yellow lines. Now, what project geometry does is, even though we're on a 2D sketch, we're looking at this flat. Project geometry will take any geometry that's either in front or behind this flat plane and sketch it up to the plane as if they were all sketched together. And this is really useful if we want to refer to something without necessarily like sketching it again. So we're going to go ahead and do project geometry. And actually, we don't really need to use it in this case because we're just creating a new circle with 3/4 inch diameter. Oh, it is useful. It's useful for not just sketches, but also extrusions. So we'll finish. And when I extrude, you can see that I can just select this outer boundary that's dictated by this outer circle here. If I hadn't projected geometry, it might try to assume that I want the full circle, which I don't. So we'll click this, and you'll see that it's going, by default, another 1.8 inches straight up. And if you're looking at the slides, you'll see that's not what I want. So for one, we want it a shorter distance. We want it 1/16 of an inch. Okay. But if you'll see that it's still not exactly what we want. If you know what a rivet is, this is a little lopsided. So we're going to click a different direction. And what that'll do is it'll just flip from the top of the sketch to the bottom of the sketch. Other options are you can like have it a symmetric direction. You can have it asymmetric, where you can define how far up it goes and how far down it goes. But for now, we're going to stick with down. Also, if there was other geometry around it, you could have it cut through. We'll be going through that later. And so we'll go ahead and do that. And just like that, we've got a rivet. For those of you who aren't familiar with what a rivet is, it's like a heavy-duty nail, essentially. Yeah, it's a fastener of some kind. So, you know, that's a great rivet, but what if we wanted to make it faster? You know, that was pretty easy. I just had to make a couple extrusions, right? But what if I wanted to use just one single function or one single feature? In this, I'm going to do it again, but we're going to use Revolve instead, just so you can see an example. So again, I'm going to start top left, 2D sketch. I'm going to click one of these planes. And now all I have to do is just draw a bunch of lines. I could do a couple rectangles and then trim a couple of the edges down, but in this case I'm going to use lines. So it snaps at the 0 degree mark, and you can see above 0 degrees, you'll see like that little symbol, and that means it's vertically aligned with the axis, or it's parallel to the y-axis. So we're going to go 1 inch up. And by the way, if I click on this box here, it'll zoom to perfection, so I can just adjust from there. So it'll censor things, and then if I just scroll, then I'll zoom out a little bit. Okay, so now I've got my 1-inch line. Let's see here. We're going to start from the bottom and go 1/16, and then go straight up. And if you're looking at the slide, you'll see that I don't actually know exactly how far up it goes. I know that there's going to be a little part at the top that comes 1/16 down. And maybe I don't want to figure out that it's 15/16. Maybe I want to do 1 minus 1/16. And ta-da, it's computer. It knows how to compute things. And again, I can do the exact same thing with how far out this goes. So, you know, if you're really good at quick maths, like go for it. But I like just typing things in as I see them. So this would be 3/8 minus 1/16, yep, minus 0.125. It doesn't matter if you mix fractions and decimals, it calculates it for you anyway. And then you'll see, it's really hard to tell. There's a really thin dotted line because it's trying to predict that I want to line up with the first line I drew. And I could just, you know, ignore it and move up anyway, and just type in the dimension I want, but we're going to snap in place like we want. And because I'm snapping in place with what it thinks I want, this line is automatically fully dimensioned. And again, when I snap in, there it goes. So you'll see this L shape is perfectly black. It's all defined. And I'm still missing one more thing, and that's my revolve line. And so it's going to be also 1 inch long. And to dimension it, we'll click dimension. And when I click the whole line, it'll assume I mean the length. Oh, okay. You're going to see this box a lot. It says, adding this dimension will overconstrain the sketch. Please accept to create a driven dimension. So what that means is the computer's like, hey, you already told me that. I already know that dimension. If you still want me to write down what that dimension is, you can by clicking accept, but it won't do anything. So we'll just hit cancel because that's not what we want. So let's try to find out what we're missing. My go-to method is to just try to click and drag things around. And so I can see I can move it side to side, but I can't move it up and down. Let's see if I can shrink it. Okay, I can't shrink it or rotate it. So that means I just have to define how far away these are. So dimension, click this, and then click this line, and then it'll try to find the dimension between the two. And that is 0.125. Great. Now just to show that this line is for sketching purposes and not necessarily part of my part, I can right click it and we'll see all these different options. You click this right one, it says construction. So when I create a construction line, it just makes it dotted. It's for personal preference. I don't think it really matters all that much if you use construction lines or full lines. But if you're taking ME 1770, you might be using these. So I'll finish sketch. And now we're going to use Revolve. So you'll see that in profiles, it's already selected this face. It's the only face available, so the computer is assuming that's what I want. What I still have to select is the axis. So all I have to do is click on select axis, make sure it's highlighted blue. And then when I hover over my construction line, it turns green. Might be hard to tell. And then as soon as I click on it, all of my different inputs have been completed and it automatically revolves exactly how I want it. I hit OK. And that is wrong. What did I do? Oh, I misread. This is not 1 inch, it's 1.8 inches. So all I have to do is double click on the dimension and I can edit it. And as you can see, so what happened here is I snapped things in place instead of telling the computer how long I wanted them, which means that when I changed this 1.8, this grew along with it. So I have to find where the source of that came from, and it's this first dimension I did, so it's 1.8, and now we're fixed. If I created dimensions properly, maybe that first change would have done everything exactly as I wanted it. That's called parametric CAD. I think we'll get into that next week. I'm throwing a lot at you guys, so if you're feeling like this is a lot and I need to slow down, say so. I'll take a look back at the chat. Okay, Tomas, you've been taking care of things. Thanks. All right. So I think if you guys really want extra practice, you can go ahead and go through the advanced CAD guide. It's the link is in further up in the chat, and it's in the email that I sent yesterday. I think I'm just going to let you guys go because I'm just going to be doing CAD. If you want me to, show you guys the advanced CAD as well, I can do that. But otherwise, you guys are good to go.